Hi guys, it's 1 a.m. tonight today, and we are going to start our first video of unseen problems on Leetcode. So first problem is the hard problem, which is largest rectangle in histogram. So how we will solve that? So basically we have an array of uh, different heights of the tower, and we need to find the largest rectangular area. So my approach would be, so suppose I consider these histograms of heights 2, 1, 5, 6, and 2, 3. So at each histogram, you can make a rectangle. So suppose that if I make the rectangle at index 0, which is of height 2, then the maximum area will be 2, because we cannot go beyond the index 0. And similarly at index 1 we cannot, uh, so basically at index 1 we can go in right direction up to the last index, which is 3, and in the left direction, which is index 0. So for simplicity I'll write this array, and along with that I'll also write the indexes here, so that you will get a more clear understanding of this problem. 0, 1, 2, 3, 4, 5. Yeah. Yes. So similarly at index 3, at index sorry, so at index 2 of height 5, we cannot go in the left direction with the same height, because we don't have any histogram greater than or less than equals to height of 5, and we can only go in the right direction because we can cover this area, right? So we will take this two rectangles, two histograms basically of index 2 and 3. So the maximum area it will cover will be the minimum height, which is 5, into length, total length we can go. So here total length will be 2 and the height will be 5. So here is 10. So yeah, this kind of intuition we have to solve this problem. So for that we have two requirements. First, we need to have the um, minimum arrays. So one minimum array will tell you the minimum value which is in the left side, and the minimum value in the right side, which will like the right minimum array will tell you. So for example, in the left minimum array, it will tell you that you cannot go beyond index 1, and another array which will tell you the rightmost minimum index, which will tell you that you cannot go beyond uh, 3. So basically you cannot go beyond 3, right? So which has height 6 and 2, and if you go beyond index 3, then you will get an histogram which is lesser than height 5, so you cannot cover this. So basically you can go up to height 6 only. So yeah, so our first task will be to find the minimum array. So what I'll do, I'll take two stacks. Yes, I'll take two stacks in that. Yes, so one stack, let me consider it as stack and st1, and similarly for finding the second array, I'll take the stack st2. Yeah, and I'll have the two array. So let me define the size first. So which is n is equals to array dot size, which is the size of the vector, and I'll define two arrays, l minimum of size n, and array minimum of size n. Mhm. L minimum and R minimum size n. Yeah, so perfect. So now our task is to find the L minimum array, which will tell you the leftmost just smaller value index, and the right minimum will tell you the right just smaller index in the right side. Yeah. So I'll traverse through the rule. I will traverse through all the array elements here. Array dot size I plus plus and so what I'll do, yeah, so I have an stack basically. So I'll open a draw.io portal and I'll show you that stack more clearly. Yeah. So basically I am having an stack here. Yeah. Mm, mm, yeah. So in stack of so basically I'll have a graph. This histogram, either this can reach on right side or either this can go in the left side. Yes. Yes. So first I'll have the condition. If our stack is not empty, so this will be the later on condition. So I want that my array should be increasing, which is the minimum array, and uh, to to make it increasing, I'll compare with the stack. Yeah. So is uh, if array minimum is greater than array dot st dot top, that means that this is an increasing order, and I am having the small. I am having the small. I'm always having the smallest element at the top of the stack. So what I'll do is I'll I'll make this uh, L minimum I is equals to sorry, that will not be a minimum, this will be I basically. So L minimum I is equals to st dot top. Yes. Mhm, yeah. So actually I'll push all the element at the last in the last, and for this condition to be valid I'll have one more condition, that st dot top must not be empty. Yeah. uh, this is, and else if we are having the decreasing value, so if we are having the decreasing value, then what I'll do is so, so I'm having the greater value in the array at index I, and the smaller values are there in the sorry, I'm having the smaller element in the array, and the greater element are there in the top of the stack. So in this case, I'll I'll keep popping the stack till till when mm, till I don't find till I don't find any till I find the uh, largest element, like till I find the greater element in the stack. So I'll do that. I'll array of st dot top uh, till they are greater than or equals to array I. I'll keep popping the elements st dot pop, and once they are popped, I'll update the L minimum. Okay, so now I will update the L minimum. So how will I update the L minimum? If our so L minimum is equals to, so if our stack is empty, right? So I'll have a condition here. If it is not empty, then it will take the st dot top value, else it will take the -1 value. Yeah, that's perfect. Yes, and at the last I'll push the element here, st dot push. This is necessary here. Yeah. So in that way, I'll make my L minimum array. And now in similar way, so what I'll do is I'll make it st1 instead of st1 dot top. Mm, 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 mm. Yeah, and similarly to calculate the R minimum, I'll traverse in the opposite direction. So it I is equals to n minus 1, I greater than equals to 0, and I minus minus. Yeah, in this case, I'll have the same condition, but in this case, I want that the value must be in, like, array values must be increasing from the right side as well. So I'll compare with the stack. Yeah, so now I'm comparing with the stack. If array I is greater than st dot array of, so actually things are same, but I'll have some modification into it. Uh, so this should always be in increasing order, as well as this should also be in increasing order. So both the side it should be in increasing order. So what I'll do is I'll check if array dot st dot top is less than array I, and for this case I'll also need to have the check on the stack if stack is not empty. Yeah, in this case, and then r minimum I is equals to uh, s2 dot top. Yes, perfect. Here I'm having st2 only. Armeno is not equals to st dot top is. Else, I'll have one more condition. Else, I'll keep traversing while my stack is not empty, and I'm finding the greater element in the stack. So array of uh, st dot top greater than equals to array I. Yeah, so I'll keep popping the stack st dot pop, and at the end I'll find the r minimum of I is equals to, and if my stack is not empty, I'll have the condition again, then I'll take the st dot top, else I'll take the n, value n. Yes, yes, yeah, yeah, that's perfect. Yeah, so now I have found both our L minimum as well as R minimum array, and one more condition I'm having, st dot push. Hmm. Hmm. No. Uh, 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 yeah. So now what I'll do is I'll calculate the uh, area of. So basically, now this is trying to calculate the area. So I'll traverse the I is equals to 0, so I is equals to n I plus plus. Here I'm having the two conditions. So the two conditions are, okay, so first I'll define the max area. So this is basically int minimum, and max area is equals to maximum of max area, comma, R minimum I minus L minimum I minus 1 into mm, now I'll also check the condition here. Yes. So if array dot size equals to 1, then what I'll do is I'll return array 0. Yes. I'll try to run the program. So yeah, I may find some syntax errors, but I'll resolve them. But I think, yeah, that's perfect. Okay, st2 here, run syntax error, st2 again. Okay. So I'm getting this error. I don't know why I'm getting this error. Let me check it again. Yeah, st1 dot top. So it should be, I think, st1 dot empty. Yes. Now I'll check the test case. Yeah, it is accepting, right? Try to submit that. If it passes the, yeah, so it passed the test case. And I think this is the most easiest approach. Uh, yeah, perfect.